The aviation world has just been shaken by a revelation no one saw coming. This time, the disruption didn't originate from the giants who have dominated the skies for decades. Instead, it came from the man who already transformed electric cars and space travel. Elon Musk has stepped beyond runways and rockets and directed his focus toward the airspace above our heads. What he has revealed is so bold that engineers across the globe are still trying to absorb what it means for the future. The Tesla Super Electric Plane, a supersonic aircraft powered purely by electricity and capable of lifting off vertically, has shifted the imagination of the industry from someday to right now. If you enjoyed this video, hit that like button. And if it's not quite your thing, go ahead and subscribe anyway, because what comes next is even more astonishing. For years, the concept of an electric aircraft was dismissed as fantasy, the kind of thing reserved for movie scenes or impossible engineering dreams. But that fantasy has finally crossed into reality. Tesla has officially announced that its revolutionary aircraft will make its public debut in 2026. And what's even more surprising is the response from regulators. The United States government and the Federal Aviation Administration have given their approval for the project. A remarkable sign that the era of electric aviation is genuinely dawning. This is no longer a speculative idea or a corporate prototype locked behind the walls of a lab. It is a direct challenge to every conventional jet engine still dominating the industry. A declaration that the old ways of aviation are now facing their greatest rival. When Musk spoke about reimagining the aviation sector, he wasn't simply referring to another flying machine. He saw the sky as the next frontier of clean energy, autonomous intelligence, and aerodynamic mastery. His goal wasn't to add a new model to an aircraft catalog, but to reshape the entire philosophy of flight. In his vision, the skies are no longer reserved for massive airliners and millionaires. They are an open canvas for sustainable travel where the average person can experience speed, freedom, and comfort without pollution or noise. Humanity is entering a new chapter, and instead of beginning on the ground, it begins above the rooftops. In the open air that once felt inaccessible, one of the biggest shocks came when Tesla revealed the aircraft's selling price. Most people assume jets cost millions, and small private models start at prices that rival luxury homes. Yet Tesla announced a price of just $79,597, figures so low that analysts wondered whether it was a printing error. The cost is dozens of times lower than any comparable jet in the market today. The world asks the same question: how could this possibly be real? The answer resides in Tesla's unique approach to manufacturing. In Nevada, the company built a facility known as the Giga Air Plant, as a counterpart to its massive gigafactories, but designed specifically for aviation. This plant turns old-school aircraft manufacturing on its head. Instead of relying on thousands of handcrafted components, Tesla uses giant gigapress systems capable of casting entire sections of an aircraft fuselage in one solid piece. This reduces production time by nearly 2/3 and cuts costs by more than half. Aviation has always been a slow, artisanal process, but Tesla transformed it into a highly automated and scalable system. Similar to how automobiles went from hand-built machines to mass-produced wonders. But manufacturing efficiency is only one piece of the puzzle. Tesla introduced a new aluminum-ion battery that costs about 40% of a typical lithium-ion pack but stores enough energy to deliver a flight range exceeding 2,000 kilometers. When produced at scale, each kilopack costs only around $45, flipping the economic model of aviation upside down. Even long-standing aerospace companies studying Tesla's strategy admit the numbers appear almost unreal. Musk added another twist: the SkyShare program. Under this model, individuals, businesses, flight schools, or families can own a Tesla aircraft by paying a monthly subscription of $4,500. It's essentially the aviation version of shared mobility platforms, allowing people to access a high-tech aircraft without owning it outright. Thousands of small companies can now afford to operate an aircraft, something unheard of in modern aviation. Tesla's AI brain, powered by the Dojo system, handles scheduling, route optimization, maintenance predictions, and resource management, slashing waste and inefficiency throughout the system. Tesla isn't building an aircraft. It is opening the sky to everyday people. One of the greatest hurdles in electric aviation has always been weight. Traditional batteries are simply too heavy to achieve liftoff without compromising range or safety. Many ambitious electric plane projects died at this stage, but Tesla's approach shattered that barrier. Their answer is the Starbolt battery, an aluminum-ion power source that represents a leap in modern battery science. Starbolt offers an energy density 60% higher than typical lithium-ion batteries. This means the aircraft becomes up to 2,000 pounds lighter for the same amount of energy, drastically improving lift, maneuverability, and efficiency. With this breakthrough, Tesla has turned the heaviest part of an electric aircraft into its greatest strategic advantage. Charging speed and lifespan also surpass expectations. Starbolt can charge at speeds up to 5 times. It's faster than previous generation batteries and offers a durability of more than 2,500 cycles. Instead of being a source of limitations, the battery becomes the core of the aircraft's strength. Tesla didn't work alone on this. They collaborated with the SpaceX engineering team to create an ultralight carbon fiber body. Inspired by the Cybertruck's exoskeleton, this design includes a unique load-distributing truss that spreads pressure throughout the aircraft. Instead of concentrating it on specific joints, protecting the fuselage during takeoffs, landings, and high-speed maneuvers. The landing gear uses aerospace-grade titanium capable of absorbing forces 6 times the weight of the aircraft, offering durability and flexibility at the same time. Every design choice serves a single purpose: overcome the limitations that kept electric aviation grounded. Safety is the core of any flying machine. Tesla approached it with the same intensity they brought to their autonomous driving systems, but amplified for the sky. The Starbolt battery underwent some of the most extreme FAA testing ever conducted. At 158 gigaseconds of force, it continued to operate reliably. At temperatures of 176 degrees Celsius, it showed no signs of swelling, leaking, or combustion. After 12 rounds of vibration simulations designed to replicate years of turbulence, the result was uneventful. Nothing happened. The battery exceeded safety benchmarks by nearly 10% and earned FAA Part 23 fire-resistant certification. Tesla also invested more than $15 billion into flight testing sites and simulation centers across the United States. These facilities produced 5,000 new high-tech jobs and positioned the country as a global leader in electric aviation research. Dojo, functioning as the aircraft's virtual co-pilot, uses insights from 10 billion miles of Tesla vehicle data to predict collisions, weather shifts, and turbulence with remarkable accuracy. Every calculation happens in milliseconds. Redundancy systems further strengthen safety. The aircraft includes 2 main battery packs, quad flight controllers, ultra-strong Tesla glass capable of withstanding pressure 5 times the aircraft's weight, and Kevlar armor around the batteries for impact absorption. Even with 2 major system failures happening simultaneously, the aircraft can still maintain flight stability. Tesla is not only meeting aviation safety requirements, but pushing them into a new era. Beyond engineering, Tesla's vision extends into the passenger experience. Instead of building a cabin that resembles an airplane, Tesla crafted an environment that resembles the future. The plane's advanced compression system maintains a cabin pressure of 8.5 COI, around 10% higher than the standard used in most commercial aircraft. This results in less fatigue, sharper alertness, and reduced cardiovascular strain at altitude. The oxygen supply system lasts up to 40 minutes during emergencies, doubling the FAA's current requirement. Passengers also benefit from real-time Starlink connectivity, weather updates, turbulence analysis, and air traffic conditions streamed directly into the aircraft's AI systems without delay. Flight paths are constantly optimized based on the most recent atmospheric data. Every movement is calculated with precision that feels invisible yet reassuring too. Passengers. The aircraft's vertical takeoff and landing capability eliminates the need for traditional runways. It can land on the rooftops of skyscrapers, in parking areas, or on office grounds. This dramatically cuts urban travel time. Trips that once required a long drive to crowded airports can now be completed in minutes. Tesla's megacharger recharges the battery to 80% in just 30 minutes, enabling 4 to 5 daily flights without strain. The aircraft's 130-mile operational range per charge covers nearly all major domestic routes within the United States. Short-distance regional flights can now be executed at a fraction of the cost and time, making electric flight not just a possibility, but the more practical option. Behind this leap forward lies a long and quiet pursuit. Elon Musk has been contemplating electric aviation for more than a decade. It was never an impulsive idea. He once explained that designing an electric jet wasn't the issue. The problem was waiting for battery technology to reach the